All right, let's add to the practice a little bit here. So I've changed the window a little bit so that it makes the graph fit better. I've gotten the calculator. This is a graph we already drew. So let's add domain and range and intervals of increasing and decreasing. All right, so domain, this thing will continue on forever to the left. There are breaks in through here. It's getting steep, but it keeps going right. So your domain in this case is all real numbers. Okay, so it's going to hit all real numbers. All right, range is where it gets a little different. It's going to go up forever on this end. It's going to come down to about 0, go back up, come down here to negative 3.1 you just found. That was the lowest y value minimum. Then it went back up forever. Okay, so in this case, range is not all real numbers, it's some real numbers. So it's anything from this minimum you found, negative 3.1, up forever. So our range, it's y values. It's any y value greater than or equal to negative 3.1. Okay, negative 3.1 is the lowest it ever hits. It is exactly equal to that. And then it's anything above it. All right, so for range, it's greater than negative or equal to negative 3.1. All right, increasing and decreasing on this one. Again, you can probably look at the graph. You can tell it's decreasing here, then it goes back up, then back down, then back up. Okay, so our intervals, we're going to have a couple decrease and we're going to have a couple increase. So let's first of all find all relative Maxima, or relative Extrema is the technical name. I did just do y values earlier. So we're going to need to find the all these x values, here, here, and here. So those are the boundaries. That's where it changes from going down to going up. Okay. So on a number line down here, that I would recommend just making some dots where where these critical points happen. So let's start with the first one on the left, the first minimum you come to. So second trace minimum, get on the left side of it, get to the right side of it, enter again, and it's about negative, that's negative 1. If you have that many zeros, that's negative 1. Okay, so at negative 1, down here on my graph, that's one of our critical points. We know it's decreased until it gets to there. So put a little down arrow. Okay. All right. Over here, looks like maybe around 1, we've got another something happening, another critical point. So second trace maximum this time, because it does max out at that point. Left bound, right bound, enter. Seems to be taking a while to calculate, but looks like 0.68. We'll just call it 2 decimal places for this one, 0.68. All right, so at 0.68, oops, no, I had it right. 0.68. It's really getting hard to read. Let's start over. 0.68, right here. All right, it's increasing in that interval. Okay. And one more critical point down here. Second trace minimum. If you're getting good at this, you can skip ahead. Just make sure you're getting the same numbers I am. Second trace minimum, left bound, right bound. You're getting let's call it 2.69. Or I'm sorry, let's call it 2.57. Sorry. We'll call it 2.57. Okay, so about 2, halfway over, 2.57. Okay. It was going down on that interval. Everything after that will go back up. Okay. So over here to the side, the way you're going to answer this, at least what I'm assuming will be on the SOL, at least to the best of my knowledge, where it's increasing would be x values that are between negative 1 and 0.68. It's also going to increase for anything that's greater than 2.57. Okay, So when x is bigger than 2.57, or if x is in this range back here, we're talking about something that's going to be increasing. Okay. And decrease. All right, 2 times any x value that's less than -1. So anything back here will be decreasing. I'm not talking about exactly equal to, because if you're exactly equal to, you're neither increasing or decreasing. You're kind of stopped in midair if you're thinking about a falling object or something you threw in the air. So don't use equal to in these. The other range, it's decreasing from 0.68 to 2.57. Okay, so hopefully that makes some sense.